Hello. So last time we talked about fundamental theorem of calculus. Let's remind ourselves what it is about. Okay. So fundamental theorem of calculus part 2 is talking about when you find the integral from a to b of a derivative function f of x dx, that represents the net change, total change, the amount. So we can use the antiderivative, try to find the antiderivative of that f of x, right, which is capital F of x, and then substitute a and a b, and then subtract. If this is a velocity, antiderivative of that will be the position function. This is like asking you what is the total change in the position. In that case, we want to find out the position function, substitute where is the ending position, final position or final amount, subtract the initial amount. So this is fundamental theorem of calculus part 2. From here, this actually leads to a lot of the question we already know that gives you the initial condition. For example, the total change of the displacement is 10 meters, but when t equal to 0, the position is 5. What is the ending position when t equals to 10? You know what I mean? So that is, you can take the final amount, f of b is equal to, move this term over, initial amount. If I give you f of a, you add the change from a to b of the derivative function. Will give you the final position or final amount. Right? If this is the water, rate of water goes into the tank, how much water is already in the tank, adding how much water you're adding in is the final amount. Okay. From here, we actually leads to the fundamental theorem of calculus, part 1. What is that? This theorem actually is the bridge between the differential calculus and integral calculus. So it's saying that if function f of x is defined as integral from a to x of f of t dt, we define the function f as integral from a to x f of t dt. Because the upper limit is x, so I'm using a dummy variable t, okay, so it doesn't overlap. When that is defined, then we can differentiate derivative of f of x is e dx of the integral. Isn't that the reverse operation? Differentiate the integral and cancel each other out, right? From a to x, f of t dt. What is this equal to? This part we can utilize our part 1. Okay? Try to find the derivative. Try to integrate the f of t into capital F of t, right? And then lower limit, upper limit. So this part becomes f of x minus f of a. Are you okay? We are taking the derivative of this. That gives us derivative of f of x, right? Separate them. Subtract derivative of f of a. And if you have a function and you substitute a number into it, isn't this a number as well? What is the derivative of a constant? 0. So this is gone. What's left is derivative of capital F of x, which is the function itself, f of x. So this becomes our fundamental theorem of calculus, part 1. Seems obvious, but remember, before 16th centuries, mathematicians doesn't know this connection between the derivative and the integral. All right, it's discovered later on. So what is the first fundamental theorem of calculus? Is that you take this part, derivative of the integral from constant. Lower limit has to be a constant. Upper limit is x. F of t dt is equal to f of x. So, okay, let's go back to look at the example we used to do last time. The simple one here. Here, see? There is a few things we need to check when we apply this fundamental theorem of calculus. Do you have derivative of the integral? Yeah. Second, is the variable, does the variable match each other? All right, this is x, this is dx matches. Number 3, is the lower limit a constant? If so, then we can just replace all the t, variable t, with x and be done with it. Okay? Then we went ahead talk about what if the upper limit is not just x, is a function, is an inside function u or g of x. So we did this all again, right? We try to integrate this f of t, become capital F of t, substitute the g of x, substitute the a, subtract. Again, the derivative of constant is 0 again. So what you end up with is f of g of x. You're still replacing that t with this g of x, but you need to add the derivative of an inside function, chain rule. So, are we good? Okay, so with that, we did a few questions last time. Did we do this one? Yes, we did, right? Okay, so when the bottom limit and the upper limit constant and the function is kind of flipped, you need to flip back by applying a negative in front of it. Okay, so let's move on to a third level fundamental theorem of calculus. Both top and bottom are functions. Yes? What do we do? Okay, so before we do this, I want to see if I can derive this. I'm going to call this bottom function h of x. So the limit is h of x to g of x. So scroll down a little bit, it look like that. Okay, so let's try to do this part. Remember how to do that? Antiderivative of f of t is capital F of t. Lower limit, upper limit. Yes? Derivative of that. Substitute the upper limit. Differentiate f of g of x. subtract. I'm gonna use a different color. Differentiate f of h of x. That is the derivative of the outside function and inside function. Derivative of capital F of x is small case f of g of x, right? You just differentiate the outside function and don't forget to chain on the derivative of the inside function. Subtract. Derivative of the capital F of x is small f of h of x, right? When you differentiate the outside function, you keep the inside function, the same, and then you chain on the h prime of x. That's our formula, the rules, when you have a upper limit, lower limit of both functions. So what do? Substitute g of x into t. All the t is replaced by that function, and multiplied by g prime. Minus, substitute the lower function, right? And then multiply by h prime. Can you use this formula to evaluate that? Okay, so what do we say? Upper limit is g of x, right? ddx of integral, so it should cancel each other out. I'm going to replace all the t with x squared. 1 over 2 plus e to the power of x squared. Don't forget to multiply by derivative of x squared is 2x. 2x. Subtract. Substitute t with the lower function. So 1 minus 2 plus e to the power of 2x. This is derivative of 2x, which is 2. Okay, write it nicely. Become 2x over that. Let's look at more examples. So, can we move down here since we just did this? Scroll down to practice. See if you can do it. All the way down. Down. 怎么没有？ Just a minute. Okay. I can do number 2. Let's do number 2 first. This is a practice. What is this? Derivative of an integral. Upper limit is a function, so this will become sine what? 2x and multiply by 2 by the chain rule. Good. These two are the definite integral. I think you're good with that. So scroll down. Let's try number 5. Oh, this is number 5 says f is defined as the integral of this. Can you find f of 3? I'm just going to substitute x with 3, right? I'm going to go by that definition of f of x. F of 3 is integral from 3 to x. X is now 3. 3 to 3 of this complicated function. What is it?
Won't it just be 0?
Yes. Yes. We learned the definite integral when the limits are the same. There is no area under that curve. So that's an easy question. Number 6. F is the integral from 3 to x. Yeah. What is f prime of x? I need to differentiate. Yes. I need to say derivative of f is d dx of the integral. Right? And then, look at that. 3 things has to happen before we apply the fundamental theorem of calculus. Derivative of integral, check. Variable match, check. Lower limit constant, check. So, what is the answer? 2x e to the power of x. Finished. Yo.
Wait, what do we, like the variable's like t, but then it's x. When do we like change the variable?
Because I need to use the dummy variable here, right? Remember when you integrate, you will substitute x into it.
Oh,
Yeah.
So the variable will never be the same as the one.
Yes,
Okay.
because the x and the t kind of overlapped. So, ladies and gentlemen, if I didn't ask you this, but I say find f prime of 1 instead, what do you need to do? Yeah, you need to find derivative function first, yeah, and then substitute f prime of 1 to b. Yeah. This is more straightforward because there's no inside function on top and bottom. If there is, then you will have to, find the function and substitute that. Okay, let's go back. Back. Right. This question. A lot of the rate change problem, including the velocity particle motion question, will be in this unit. And everything you learned before, you need to still remember. For example, if I provide this graph, this is the velocity graph. What does that mean when the velocity is positive?
Right.
The particle is what? Moving to the right. When the velocity is negative, it's moving to the left. Therefore, the area integrated when the graph is positive, that is how many meters moving to the right, positive direction, right? When you integrate the graph, which is lower than the x-axis, that's how many meters moving to the opposite direction. So you need to know this. Yeah. Good. Let's see. Let's label this A, B, C, D, E. So we have the velocity graph from 0 to 6 seconds. Velocity being meters per second. How far did the particle move to the right? Can you write the expression, integral expression, indicate that? Not just give me the answer, and you write the integral notation. How much does the particle move to the right? Yes. So Martin, for that, I need to write what?
So integral 4, 0.
0 to 4.
Zero
Yeah,
to
0
4,
to
yeah.
4. And d of t dt.
Yeah.
Yeah. And can you calculate the area? How much is that?
5.
5? Okay. 5 meters, right? You have to answer with a complete sentence. The particle moved to the right 5 meters. Answer in a complete sentence. Now, next one is how far to the left? When velocity is negative, it's moving to the left, and that's how much. So, Iris, can you help me with the integral notation? What is B?
Integral from 4 to 6.
Good.
dt.
d of t dt. And what is that?
1.5.
1.5, but be careful because I am writing in the integral notation and this is below, so the sign should be
Negative.
-1.5. Why is that negative?
It's going to
Yeah, so you have to answer. So the particle move to the left is actually expanding the negative 1.5 meters. Good. C, what is the displacement? Displacement, integral notation. Emmy, can you help me with the integral notation?
integral
0
0 to 4.
to 4. Total displacement, the first six seconds. 0 to 6. Yeah, d of t dt. And what is your answer?
6.
Sorry, it's supposed to be 5, right? 1.5. So displacement is the net change. This is actually negative. Move to the right and come back. So your displacement is 5 minus 1.5, which is 3.5 meters. Ending position, subtract the starting position, only move 3.5. All right, D, if the particle starts at the position of 7, oh, there you go. That is telling you S of 0 is 7, right? I move 3.5 meters, but if I started at 10, then I will be at the 13.5. If my starting point at negative 10, move 3.5 to the right, it will be negative 6.5. So this is, remember our fundamental theorem of calculus. I want to find ending position at 7, S of 7 is equal to S of 0, initial position, plus the change from 0 to 6, v of t dt. Super important. I can say, okay, the sink initially have 500 gallons of water. Over the 6 hours, this is how much water is added. How much water in total at the end of the 6 hour? See, that's the same question. So 7 plus 3.5. Position at t equal to, 老师写错了. This is wrong. Sorry, and I misread it. T equal to 6, right? This should be S of 6. 0, 0 to 6. Okay, E, What is the total distance travel over the 6 second? What do you think, Mia?
Oh,
Yes.
minus.
I need to add, okay? But what is my notation if I use the integral? What is it?
Absolute value.
I need to take the absolute value because distance is integral of speed. Speed, there is no positive, negative speed, right? Speed is always positive. Speed is absolute value of velocity. In other words, I want to flip out the graph at the below up. So I can add all the area. So when you write this, it should be integral from 0 to 6, absolute value of v of t dt. Represent the distance traveled. And that will be 5 plus 1.5. Travel 6.5 meters. 5 meters to the right, 1.5 to the left. Okay. Sure. Okay, the particle movement question. So this is the same as the integral of the rate. For example, if I give you the cost, C of x is the cost of producing x unit in a certain commodity. S prime, how much more cost, right? The cost per item. C prime of x is the marginal cost from the theorem, integral from x1 to x2 of C prime. You can say, okay, how much is the cost producing 10 items? Subtract how much it costs producing 9 items. That will be the cost producing that extra 1 item. Yeah, does it make sense? Again, this is fundamental theorem of calculus part 2. You are trying to find the antiderivative of C prime, which is C, substitute the upper limit, subtract the lower limit. Yeah, all the same, all the same. Okay, let's revisit this particle motion problem. If the object with the position function s of t moves along the coordinate line, what is the velocity function from s of t? S prime of t, very good. I need to differentiate to find velocity function. Therefore, the theorem says integral v of t from t1 to t2, it will be what? You need an antiderivative of that, which is find the position function, substitute t2, subtract t1. We already know this, right? Your ending position, subtract the starting position, is your net change, total displacement. So what you're looking at is the total displacement, integral from a to b, v of t dt. Over the time interval, t1 to t2. On the other hand, the integral of the speed, if v of t is the velocity function, what is the speed? Absolute value of v of t, yes. It will be if you integrate the speed, when you find it, it will be the distance traveled. Because you flip, when you're taking the absolute value, all the negative graph become positive graph. So, integral from t1 to t2, absolute value of v of t dt will be the value integral notation for total distance traveled. Okay, let's look at that right here. All right, next. This is review from last class. So this question, I can just give you the question like this without the graph. When I give you the graph, it's kind of easy for you to see. Oh, this is positive and this is negative, right? When I ask you to find the total area, remember I want to add the positive area as well as the negative, integral here. So without the graph given to you, what is your first step to find the total area bounded between the graph and the x-axis? What's your first step? Find the zeros. Where do they intersect? Right? You need to be able to graph actually. So number one, can we find zeros? By setting x cubed minus this. Okay, factor. X minus 2 plus 1. There you go, I have 3 zeros, okay? 0, 2, negative 1. Then you can sketch. And think about what is the function, cubic function look like with the leading coefficient positive, isn't it? This, right side up. So when you plot your zeros, I need to go up and down and up. So once you have your graph, it's obvious this part of the graph is above x-axis. So when I find integral from negative 1 to 0, it will be positive. But 0 to 2, graph is negative. So if I integrate 0 to 2, I become negative. So I cannot just say integral from negative 1 to 2, right? Let's say this is f of x. That will not give me the total area. It actually give me, this is A, this is B, A minus B. But I want A plus B, right? That's wrong. So what should we do? We need to separate. Calculate it in 2 integrals. For this part, we want to write integral from negative 1 to 0. I'm going to define this as f of x, so I don't need to write the whole thing. F of x dx. How should I manipulate my second part so it's positive? Anybody? Minus. If I do minus, the limit should be 0 to 2. Yeah. Or I can find the 0 to 2 and then take the absolute value. Or I can add, I can,
2 to 0.
Yes, flip 2 to 0. So whatever you want to do, yeah? Just make sure it's positive. All right, the rest you can just do the antiderivative. Sub in the upper limit, subtract the lower limit. So you can do that. All right. Okido, move on. Next. Yes, everybody know how to use the calculator to find the integral, okay. So this is a little guide in case you forget. You can go to alpha window. Number 4 is the finite integral. Number 1 is absolute value. Yeah. Okay. Do the rest on your own. So I'm going to give you a lot of free response questions to practice because there's so many various type of application problems with the integration, definite integral, and the fundamental theorem of calculus. So let's start from, I already posed, this is day 6 homework. Yeah. I'm going to start with this question. This is I believe, a calculator question. Yes, calculator question. Can we do this together? I'm gonna pause. Everybody work on this